Hello again. All right. Let's go over some of the answers from yesterday to make sure that you really got an understanding of what all those critical thinking questions were all about. Ladies and gentlemen, the first one was all about outcome measured, okay? Was the claim treatment outcome actually measured? And in this one, it's a yes, okay? It's a yes. They did measure whether or not births were impacted by their experimentation. But you always gotta be really careful, okay? There's a lot of weird claims that come out there and a lot of pseudoscience where you kind of take like random variables and then use that to justify your claim. And for the most part, that's not really how science works. You have to have a very strong experiment in order to really change people's minds on, what's going on and how things are happening. So for this one, it is a yes. Now, remember, if you need, you can just read that. These are the answers that I'm posting so you can understand where it's coming from. If there's any problem, please just, send me an email. I can send you these directly so you can reread them, okay? Next one up, part 2, or question 2. All right. For the second part, it was all about control, and a lot of people got this wrong initially. And there's a reason why. When you're doing big trials, especially with humans, it's not like some of our experiments where it's really easy to have the control, which is just water, and then the rest of the experiment, which is different levels of pH. In humans, it's a lot of different variables all having an impact. So you gotta be really careful with how you're making a control. That's why certain things like developing a vaccine takes so long to do, because you have to do your very best to decrease those other variables, okay? Ladies and gentlemen, in this case, while there was a group that was set aside to act as the control, it was not the appropriate control, okay? The control group was not otherwise similar. Treated women knew they were being treated. Untreated women knew they weren't being treated. So it gets us into a couple issues of what happens when somebody knows they're being experimented on. We have a huge issue with placebo effect, that if you believe something is going to work, it will. And that's scientifically proven. Yes, placebo effect is real. People can convince themselves of certain treatments working, regardless of whether or not they are. And that belief can actually cause them to become healthier. It's a remarkable situation that humanity puts itself in, where our mind is strong enough to change our body. It's pretty crazy stuff. So then again, that's what's going on with this. On to the next part. All right, was this treatment replicated? Okay, and here it is. Yes, they used a lot of women. They used different pairs of women here, 132. That's way different than one person being experimented on, okay? Ladies and gentlemen, coin flip, what's the chance of getting a tails? Let's see. I got a head. Therefore, this quarter will always give me heads when I flip it. I did it once, I proved to you, right? That's data, but it's not very good data. Flip this coin 100 times, and then you tell me what your chance of getting heads or tails is. Same type of thing with this type of experiment. Was there replication there? Yes. All right, number 4. Was the treatment allocated randomly? Let's take a look. Yes. So, they did not take only women between the age of 20 and 30 and do the experiment on them, and then women having birth between the age of 30 and 45 and do the experiment on them. They randomized to the best of their ability. That's important. You need to be fully random to see if real science is coming about in your selection of participants, okay? Fully random. Next up, Whether or not you can do this research again. Was it reproduced, okay? In this case, they're saying this experiment, it wasn't reproducing other experiments, it was the first time. So anytime science does that, you say, whoa, 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 do that again. We had a problem with stem cells with this. I think it was 2010, 2012, I'm not really sure, it could have been 2008. They made this big thing where you could change any cell into a stem cell. And then it turned out it didn't really work too well. Their whole procedure had issues with it. Their experiment was flawed. And after some other scientists tried to do it, the results weren't the same. That's a huge issue when it comes to making science. That's a huge issue to making these kind of developments. And when a scientist says something, when a researcher says something, there must be real evidence supporting it, okay? Last one for question 1. Are these results consistent with established science? I know some of you might say, who cares about established science? What do they know? Established science is not the classroom experience that you've had as a high school kid. Okay, it's not. It is everything else that waits for you in the future of your exploration into science. Hopefully something that you go and end up making more money than me and saving the world while you're at it, okay? Being one of those heroes that are out there that we used to celebrate every day at 7 o'clock, or being one of those heroes that go and make the world a better place by saving lives, all right? Established science is the type of thing that after everyone tears it down, it still stands the test of time, okay? Scientists get famous by disproving other scientists or saying whatever you were saying was wrong. Well, if you can't do that, it means whatever is being discussed, whatever is being experimented on really has a good, solid foundation to stand. Well, plausibility. Does this come about from regular biological mechanisms? And the answer is no, it is not. Putting a hot needle on a pregnant woman's toe is not some known scientific mechanism that makes sense, and then you can start saying, oh, okay, this is definitely how it works. It's based on a lot of different ideas or approaches to energy that may or may not really be doing what they expect it to be doing. That doesn't mean everything is known. That doesn't mean that science has figured out everything. That means science is trying to figure something out. And until you have some real deal evidence that cannot be refuted, you gotta go slow, okay? We don't run into saying things that you can cure all these issues by just doing certain things. There's a reason why. There's backlash, right? There's backlash. And also, I told you before, scientists get famous by disproving other scientists. So if you start saying false claims of magic treatments of certain viruses, scientists are going to rip you down and say that's not how it works, because they're actually going to go and do the test. Okay, so right down here, this is the last big thing. The claim that moxibustion is helpful in positioning of the fetus is not well justified. A major flaw in the evidence is a lack of proper controls. A better test of this claim would improve by double blinding the experiment. That means you have to give a treatment to the control group that it's completely not right, where they would think they're being the experimental group, but they wouldn't know it. That way you kind of, you decrease that placebo and you make it so it's not so easy to have mistakes going on in your data. All right, question 2, here it is. Question 2 was weird. You had to look at different data and come to different understandings of what the data means. You were supposed to come up with one of these 4 problems with the data. And don't worry if you didn't figure it all out yet. You got all year to practice. But it's this type of critical thinking, of skeptical thinking, that will inoculate you to others who say whatever they want And it usually has to do with making a few bucks, but then people believe it. People follow along. You need to be able to stop charlatans from persuading you into false science, pseudoscience, and misled research. So let's see if you got any of these results. Again, if you didn't, relax, it's okay. It's day one of real learning. All right, so here we go. Here's your 4 choices. All right, the first one, the position of the outcomes of the trials with large sample sizes suggests little evidence of a treatment effect of acupuncture on a stroke, okay? So, if you take a large sample size, you can get weird kinds of spreads, okay, of data points. That doesn't mean a lot of participants is bad. It's actually a good thing, but still, that's why you would do something like test the medicine on 10,000 people and then test it on 150,000 people. And then as that medicine is used, you still keep track of all the possible effects that medicine is having. That's why some medicines later down the road get pulled off because they're like, oh no, this ends up being something that has negative impacts. It's not worth the benefit of the treatment. It's a never-ending process for science. Number 2, the lack of symmetry is suspicious. We would expect additional points to the left of the plot. That has to do something with possible bias in the experimenter, which means these results don't seem to really be on the same spread of things that are random. Okay, a lot of reasons why that might be. The lack of symmetry suggests the possibility of publication bias. Yay! A tendency for negative outcomes to not be published. Welcome to how I got through organic chemistry lab in college. When I got results that weren't good, I knew they weren't good, they were bad, and then I took other results that were good and fit into what they were supposed to be. Don't do that. Real science loses credibility if we do that. If we say, this is what's supposed to happen, let's do everything to make it happen, that's not science. At all. At all. Science is the opposite. What is supposed to happen? Well, it's not happening here. Let's rip that down. Let's rip that down. That is not good science. And I can support it with good experimentation. I wasn't doing normally good experimentation. I was usually mistaking things and not measuring correctly and not cleaning accurately. And it led me to having a lot of issues when it came to getting the results I wanted to in a chemistry class. Some of you are probably better at that than me. I think you have a future in it if you are. Keep going. Other factors could also explain the shape, such as disproportionately poor responses of control subjects in small trials, recognition of the possibility of publication bias, and important to learn the outcome. So, how can you get messed up data? Right here. Here's a good explanation of what you're supposed to be seeing. And if you didn't come up with that answer right away, you had a different answer, that does not mean you are wrong. There's a lot of different ways data can be misinterpreted, okay? I hope that clears up some of the topic that we went over, and yeah, see you soon.